Hello learners, welcome to the course Statistical Methods for Economics, Random Variable and Probability Distribution. In this session, we will discuss the concepts related to random variable, concept of probability distribution for a discrete random variable, approach to solving the problems of a discrete random variables, concept of probability distribution for a continuous random variable, approach to solving the problem of a continuous random variable. In the previous session, we have discussed the concept of inverse probability, approaches of inverse probability such as Bayes theorem and tree diagram method. With the help of examples, we have seen how the problems of inverse probability can be solved using Bayes theorem and tree diagram method. Concept of a random variable and random experiment. A random experiment is a process that has multiple possible outcomes and the outcome of the experiment is uncertain or random. Examples of random experiments include flipping a coin, rolling a dice, and picking a card from a deck. In each of these cases, there are multiple possible outcomes, and the probability of each outcome depends on the specific experiment being conducted. By a random variable, we mean a real number x associated with the outcomes of a random experiment. Let us consider an experiment of tossing fair coins. Then the sample space is HH, HT, TH, TT. We shall assign a number for the sample point TT as 0, HT as 1, TH as 1 and HH as 2. The number assigned here indicates the number of heads obtained in each case. Let the number of heads be denoted by x. Then x is a function on the sample space which takes the values 0, 1, 2 with respective probabilities 1 by 4, 2 by 4 and 1 by 4. That is, probability of x is equal to 0 is equal to probability of no head, which is equal to 1 by 4, and probability of x is equal to 1 is equal to probability of one head, which is equal to 2 by 4, and probability of x is equal to 2 is equal to probability of 2 head, which is equal to 1 by 4. Here x is called as a random variable or a random variate. As an activity, you can consider the random experiment is rolling a 6-sided dice. A possible random variable could be the number that appears on the dice. In this case, the possible values on the random variable are 1, 2, 3, 4, 5 and 6. The probability distribution of a random variable describes the probability of each possible value occurring. For example, in the case of rolling a 6-sided dice, each possible values has an equal probability of 1 by 6. Hence, a random variable is defined as a mathematical function that assigns a numerical value to each possible outcome of an experiment. The value of a random variable can be thought of as a measurement or observation of the outcome of the experiment. Random variables are commonly used in probability theory and statistics to model and analyze uncertain events. They are also used in many real-world applications such as finance, engineering and physics to model and predict outcomes of random processes. Random variables are classified as discrete random variable and continuous random variable. Discrete random variable. If the random variable x assumes only a finite or countable infinite set of values, it is known as a discrete random variable. Example of a discrete random variable include number of students in a college, number of accidents in a busy road, the number of defective items in a production line, the number of customers in a queue at a specific time, etc. Continuous random variable. If the random variable x assumes only a infinite and uncountable set of values, it is said to be a continuous random variable. The examples of a continuous random variable includes age of students in a class, height of students in a class, the amount of rainfall in a given area, and the time taken to complete a task, etc. In each of a continuous random variable, we usually discuss the value in a particular interval and not at a point. Probability distribution of a discrete random variable. To describe the probability distribution of a discrete random variable, we need to specify two things: the set of possible values that the variable can take and the probability associated with each value. Now, we shall define the probability distribution of a discrete random variable. Let x be a discrete random variable with possible values x1, x2, etc. xn. Then the probability distribution of x is given by the set of probabilities. Probability of x is equal to xi for each I is equal to 1 to etc. to n. The function is said to be a probability distribution if it satisfies the following conditions. First one is that the probability of each possible value x is non-negative. That is, probability of x is equal to xi should be greater than or equal to 0 for all values of I is equal to 1 to etc. n. The second condition is that the sum of the probabilities of all possible value of x must be equal to 1. That is, summation I is equal to 1 to n, probability of x is equal to xi is equal to 1. If the above conditions are satisfied by the random variable, then the random variable is called as the probability distribution function. The function p of xi is equal to p of x is equal to xi is called the probability mass function of the random variable x, which is abbreviated as PMF, and the set of all ordered pairs xi, p of xi is called the probability distribution of the random variable x. The probability distribution of the discrete random variable can be presented in a tabular form as shown. Probability distribution of a continuous random variable. To describe the probability distribution of a continuous random variable, we use a probability density function. To understand the concept of probability distribution of a continuous random variable, let us recall the graphical representation of constructing a histogram and frequency polygon for a grouped frequency distribution for a continuous variable. A frequency polygon gets smoother as the sample size gets larger and the class interval become more numerous and narrower, which results in the density polygon becoming a smooth curve called the density curve. The function that defines the curve is called the probability density function. Now, we shall define the probability distribution of a continuous random variable. Let x be a continuous random variable taking values on the interval a, b. A function f of x is said to be a probability density function, which is abbreviated as PDF, of the continuous random variable x if it satisfies the following conditions. Firstly, f of x should be greater than or equal to 0 for all x in the interval a to b. Secondly, for two distinct numbers c and d in the interval a, b, probability of c less than or equal to x less than or equal to d is equal to area under the probability curve between the ordinates at x is equal to c and x is equal to d. Lastly, the total area under the probability curve is 1, that is, probability of a less than or equal to x less than or equal to b is equal to 1. Certain points are to be noted while dealing with probability distribution of a continuous random variable. They are the area under any probability curve with probability density function f of x between x is equal to c and x is equal to d can be obtained by using the technique of integration from integral calculus. That is, probability of c less than or equal to x less than or equal to d is equal to integral from c to d f of x dx. In case of continuous random variable, the probability at a point is always 0. That is, probability of x is equal to c is equal to 0. Distribution function or a cumulative probability function. If x is a random variable with probability function p of x, then the distribution function, usually denoted by f of x, is defined as f of x is equal to probability of x less than or equal to x. Note that if x is a discrete random variable taking values x is equal to 1 to etc., then f of x is equal to p of x is equal to 1 plus p of x is equal to 2 plus etc. plus p of x is equal to x. And if x is a continuous random variable with probability density function f of x, the distribution function is given by f of x is equal to probability of x less than or equal to x is equal to integral minus infinity to x f of x dx. Now, we look into the practical approach of the concepts discussed. A die is tossed once. Getting an odd number is termed as a success. Find the probability distribution of the number of successes. In the experiment of tossing a dice once, and the favorable cases to getting an odd number is 1, 3, 5. The probability of success is 3 by 5, which is equal to 1 by 2. And then the probability of failure would be 1 by 2. Now, define a random variable x as the number of successes in throw of a die. Then the possible values that x can take is 0 and 1 with respective probabilities 1 by 2 each. Hence, the probability distribution of x is probability of x is equal to 0 is equal to 1 by 2 and probability of x is equal to 1 is equal to 1 by 2 and is as shown in the table. Two cards are drawn successively with replacement from a well shuffled deck of 52 cards. Find the probability distribution of the number of aces. In the given experiment, let us denote the random variable x as the number of aces obtained in a draw of 2 cards. Hence, x can take the values 0, 1, 2. We have probability of drawing an ace 4 by 52, which is equal to 1 by 13, and the probability of drawing a non-ace is 1 minus 1 by 13, which is equal to 12 by 13. Since the cards are drawn with replacement, all the draws are independent. We have probability of x is equal to 0 is equal to probability of getting a non-ace in the first draw and a non-ace in the second draw, which is equal to 12 by 13 into 12 by 13, which is equal to 144 by 169. Probability of x is equal to 1 is equal to probability of getting a non-ace in the first draw and ace in the second draw plus probability of getting a ace in the first draw and a non-ace in the second draw, which is equal to 1 by 13 into 12 by 13 plus 12 by 13 into 1 by 13, which is equal to 24 by 169. Probability of x is equal to 2 is equal to probability of getting a ace in the first draw and a ace in the second draw, which is equal to 1 by 13 into 1 by 13, which is equal to 1 by 169. Hence, the probability distribution of x is as shown. A random variable x has the following probability function. X is equal to 0, p of x is 0. X is equal to 1, p of x is 1 by 10. X is equal to 0, p of x is equal to 0. X is equal to 1, p of x is 1 by 10. X is equal to 2, p of x is 2 by 10. X is equal to 3, p of x is 2 by 10. X is equal to 4, p of x is 3 by 10. X is equal to 5, p of x is 1 by 100. X is equal to 6, p of x is 2 by 100. X is equal to 7, p of x is 17 by 100. Evaluate probability of x less than or equal to 6. Probability of x greater than or equal to 6. Probability of 0 less than x less than 5. First, let us verify whether the given distribution is a probability distribution or not. A function is said to be a probability function if summation px is equal to 1. That is, adding 0, plus 1 by 10 plus 2 by 10 plus 2 by 10 plus 3 by 10 plus 1 by 100 plus 2 by 100 plus 17 by 100, we get their sum is equal to 1. Hence, the distribution is a probability distribution. Now, probability of x less than or equal to 6 is equal to probability of x is equal to 0 plus probability of x is equal to 1 plus probability of x is equal to 2 plus probability of x is equal to 3 plus probability of x is equal to 4 plus probability of x is equal to 5 plus probability of x is equal to 6, which is equal to 0 plus 1 by 10 plus 2 by 10 plus 2 by 10 plus 3 by 10 plus 1 by 100 plus 2 by 100 plus 17 by 100, which is equal to 83 by 100. Now, probability of x greater than or equal to 6 is equal to 1 minus probability of x less than or equal to 6, which is equal to 1 minus 81 by 100, which is equal to 19 by 100. Now, probability of 0 less than x less than 5 is equal to probability of x is equal to 1 plus probability of x is equal to 2 plus probability of x is equal to 3 plus probability of x is equal to 4, which is equal to 1 by 10 plus 2 by 10 plus 2 by 10 plus 3 by 10 plus 1 by 100 plus 2 by 100, which is equal to 2 by 5, which is equal to 4 by 5. Summarization. In this module, we have discussed about the concept of random experiment and random variable. Also, understood the concept of probability distribution, the discrete and continuous probability distributions, and the cumulative probability function. Then, we have solved some examples on the concept discussed, which gave us the clarity about how the theoretical concepts are applied practically. Thank you.